In previous lessons, we were introduced to quadratic expressions in which an unknown term was raised to the power of 2. In this lesson, we will now turn our attention to quadratic equations. In algebra, a quadratic equation is any equation having the form ax squared plus bx plus c equals 0, where x represents unknown values and a, b, and c represent known values. For an equation to be quadratic, the value of a must not be equal to 0, although the values of b or c may be equal to 0 in some cases. Note that the difference between a quadratic expression and a quadratic equation is the equality sign. Quadratic expressions, as we saw in previous lessons, do not contain the equality sign, while quadratic equations, on the other hand, contain the equality sign. An example of a quadratic equation is 2x squared minus 5x minus 3 equals 0. Another example is n squared plus 50 equals 27n. Yet another example is 0 equals 4a minus 9 in a bracket and 2a plus 1 in another bracket. And our last example is 49 equals k squared. Do you know why 0 equals 4a minus 9 in brackets and 2a plus 1 in another bracket is a quadratic equation? Try opening the brackets and see the result you'll get. That will make you see why it is a quadratic equation. I'm sure you remember that numbers attached to unknowns are called coefficients. Let's again look at the general form of a quadratic equation. Ax squared plus bx plus c equals 0. A, b, and c are the coefficients of the equation and may be distinguished as follows. A is the quadratic coefficient, b is the linear coefficient, and c is the constant or free term. You would have also observed in the examples of quadratic equations which I mentioned earlier that they do not always strictly comply with the format ax squared plus bx plus c equals 0. This is because the order of arrangement doesn't matter. What matters is that the equation contains the quadratic term. The values of x that satisfy the equation are called the solutions or roots of the equation. Simply put, to solve a quadratic equation means to find its roots. Notice that I said roots, not roots. This is because, unlike linear equations, quadratic equations have two solutions or roots, which may be the same or different values. That is, the roots of a quadratic equation may be two different numbers or a single number. Where there is only one number, we call it a double root, because the roots of the quadratic equation are the same number repeated twice. So, a quadratic equation always has two roots. In subsequent lessons, our objective will be to explore ways of solving quadratic equations. That is, finding the values of the unknown that make the equation true. Join me on this exciting ride as we explore the world of quadratic equations.